10, 12, a sign is suspended by two wires. Let me make this big so you can see. Wire 1 and wire 2, as shown in the figure. Is the tension in each wire larger than, equal to, or smaller than the gravitational force exerted on the sign by the Earth? Okay, again, as always, please try it yourself and then see what you know, see what you don't know. Okay, so what would be the first step? So we're trying to see, there's a tension in this wire, there's a tension in this wire, and we're trying to see, is this tension the same, larger or smaller than the gravitational force pulling this down? So we know that we've got Fg pulling this down, right? Earth on the sign, okay? So this is gravitational force. And we know that these two wires are suspending it, right? So this sign is in equilibrium, so there's no acceleration in the x direction, there's no acceleration in the y direction. Okay, so what's happening in these wires in relation to this gravitational force? So what would be the first step? What do you think is the first step? Well, for me, the first step always is to draw a free body diagram. So here is our body. There, we can call this one F1. Okay, and this is tension in this cable, and this is going to be 20 degrees, and we have this force there, F2, and that is 40 degrees, and then we've got this gravitational force here. Okay, so that's the first step, is the free body diagram. Now we are trying to get F2 in terms of Fg. We're trying to directly relate them because we want to see, is F1 the same, larger or smaller than Fg? So we want F1 and Fg in a kind of a relation, in an equation, and we want F2 and Fg. So if we start with some of the forces in the y, by the way, some of the forces in the y, is there an acceleration in the y? No, so this will be 0 because there's no acceleration in the y direction. Now what are the forces in the y? The forces in the y are F2 cos 40 plus F1 sine 20, right? Sine 20 equals, let me do it this way, just so that it's absolutely clear, minus Fg equals 0. But then you could actually what? Move that over to the other side, and so it equals Fg. Those two positive components equal this negative component, right? So this is fine. This is absolutely fine. But the problem is that we have both F2 and F1 in terms of Fg, or Fg in terms of F1 and F2. So what are we going to do? We're going to say, well, sum of the forces in the x equals 0. So pause the video and see if you can write out the force components in the x direction. Please try that. Please pause the video and try. Okay. Alright, so I'm glad you paused the video. So we've got F1. What is this component? F1 cos 20 minus F2 sine 40 equals what? Equals 0. There's no acceleration in the x direction. This object is in equilibrium. Okay? Even it's called static equilibrium. Static equilibrium. because you can have something moving that's in equilibrium, which means that it's moving but it's got a zero acceleration. This is not moving, and it's in equilibrium. Okay, so this is helpful because now I can get, for example, I can get F2 in terms of F1, and I've done this before. So if you rearrange this, you're going to get F2 is F1 cos 20 divided by sine 40, right? Let me just see, is that right? Have I done it right? F2 is F1. I think I've made a mistake at some point. Let's see. F1 should be cos 20, and then F2, I think it's right. I think it's right. So let's make, that's where I made my mistake. F1 is equal to, I'm going to redo this because when I did my working out, I had this as F2 and that as F1. So let me just make 100% sure. So F1 is going to be F2 sine 40 over cos 20. Sorry for wasting your time there. So F1 is 0.68 F2. F1 is 0.68 F2. Okay. Now, what we can do is we can go and substitute this back into there, right? We've got F1 in terms of F2. We can go and substitute this back into there. Then we are just going to have these F2 terms. We're going to have F2 cos 40 plus, what is this? This is 0.68 F2 times sine 20. And we are going to have that, we're going to basically have 0.999 F2 is the gravitational force, right? So the reason why I've got this is because I used the calculator and not the trigonometric ratios. So this actually should be 1. So what we can see here is that F2, this force, is the same as this force. That force there, in that tension in that cable, is the same as the gravitational force. But F1 is then 0.68 times the gravitational force. Okay? So all you need to do is plug that in there and you'll see that F1 is 0.68 times the gravitational force and F2 is practically the same as the gravitational force. Okay? I hope that makes sense. If you don't understand, shoot me an email. Okay? Cheers.